Except for the two elements in the first row or period of the periodic table, main group elements want to have as many valence electrons as the noble gases, which is 8. Noble gases are chemically unreactive because they have 8 valence electrons, which is as stable as it gets for electrons. The octet rule is based on the stability that comes from having 8 valence electrons. The octet rule states that main group elements, except hydrogen and helium, react so that they have 8 valence electrons. How an atom achieves an octet varies. Nonmetals can gain electrons to form ions to obtain an octet. Nonmetals are also able to share electrons to obtain an octet of electrons. On the other hand, metals always lose electrons to obtain an octet. In general, metals do not share electrons and will lose electrons or get oxidized to become more stable. I mentioned the term ion, which we haven't defined yet. Ions are atoms or molecules with unequal number of protons and electrons, so there is an overall charge. Atoms with an unequal number of protons and electrons are known as monoatomic ions. Molecules with an unequal number of protons and electrons are known as polyatomic ions. Ions with a positive charge are known as cations. Cations have more protons than electrons. Most cations are monoatomic and are formed from metals or hydrogen. There are a few polyatomic cations. On the slide is the formula for several cations. The sodium cation, capital N lowercase a with a positive charge to the upper right of the symbol. The calcium cation is capital C lowercase a with a positive 2 charge in the upper right of the symbol. These are both monoatomic cations, and they are both from metal atoms which have lost electrons. The last example is a polyatomic cation known as ammonium. We see from the formula that there is 1 nitrogen and 4 hydrogen atoms. The formula is capital N, capital H subscript 4, and a charge of positive 1. Notice that the charges are written on the upper right of the symbol or formula. Ions with a negative charge are known as anions. Anions have more electrons than protons. Anions are formed from nonmetals, and most polyatomic ions are anions. Some examples of anions are chloride, capital C lowercase l, and a charge of negative 1 in the upper right. Oxide, capital O with a charge of negative 2 in the upper right. Both of these are monoatomic anions. The last example is a polyatomic anion, as we see from the formula that there is 1 phosphorus atom and 4 oxygen atoms. The formula is capital P, capital O subscript 4, and a charge of negative 3 to the upper right of the formula. Ions are incredibly important for cellular functions. Table 3 of the text highlights the importance of a handful of ions. Notice that the cations are monoatomic and derived from metal atoms, while most of the anions are polyatomic.